6.0.0 Wiring devices. Explain how to select and install various wiring devices. Explain how to install receptacles, switches, and devices near residential swimming pools, spas, and hot tubs. 6.1.0 Working with receptacles. Receptacles are rated by voltage and amperage capacity. I'm going to make that a highlight. You'll find the regulations for receptacles in NEC Article 406. NEC Section 406.4a requires that receptacles connected to a 15 or 20 amp circuit must have a correct specifications for the applications and be of the grounding type. NEC Section 406.12 requires that all 15 and 20 amp, 125 and 250 volt non-locking receptacles installed in dwelling units shall be listed as tamper resistant. All right, so that sounds to me like both of those are probably highlights. And on a circuit, if you have a single receptacle on a dedicated circuit, the receptacle has to have a rating equal to or greater than the rating of the circuit. In other words, if you have a 50 amp single receptacle for a range, it has to be on a circuit that is rated no more than 50 amps. It can be on a circuit that's rated 40 amps. The receptacle rating has to be equal to or greater than the individual circuit. Now, that's different when you have more than one outlet, when you have more than one receptacle. On branch circuits in the living room or small appliance branch circuits in the kitchen, you can put 15 amp receptacles on a 20 amp circuit. The receptacles themselves are rated at 15 amps, but you can have more than one of them and they can be on a 20 amp circuit. All right, we'll see if they mention that. NEC Section 406.4d has several requirements for the replacement receptacles as shown in Table 8. So, the replacement must be of AFCI protected if specified elsewhere. The replacement must be tamper resistant if specified elsewhere, and the replacement must be weather resistant if specified elsewhere. Where there's only one outlet on a circuit, the receptacle's rating must be equal to or greater than the capacity of the conductor feeding it. That sounds familiar. There. For example, one receptacle is connected to a 20 amp residential laundry circuit. The receptacle must be rated at 20 amps or more. When more than one receptacle outlet is on a circuit, the total connected load must be equal to or less than the capacity of the branch circuit conductors feeding the receptacles. So when you have a 20 amp small appliance branch circuit, you're allowed to put 15 amp or 20 amp receptacles on that circuit. Refer to Figure 71 for some of the characteristics of a standard 125 volt 15 amp duplex receptacle. Note that the terminals are color coded as follows. Green is for the connection for the equipment grounding conductor. The silver screws for the connection of the neutral or grounded conductor. And the brass is for the connection of the ungrounded conductor. Let's go over these. What does this say? It has plaster ears with break-off tabs. If you put these in a 4 square box with an industrial plate, then you need to break these ears off. Mounting screw slot is 3. COALR, that means it's good for copper or aluminum. COALR indicates switching capability with copper and aluminum wire. 4 is the longer slot. It indicates it's the neutral or ground dead conductor. 5 is the smaller slot. It indicates it's the ungrounded conductor. 6 is the grounding slot. 7 is the neutral or grounded terminal. They're indicated by a silver color. 8 is the amperage and voltage rating, 125 volt, 15 amp. 9 is the CSA symbol, saying that it's approved in Canada. Here, 10 is the ungrounded conductors are connected to the brass screws opposite the grounded conductor screws. 11 is the UL, Underwriter Laboratory listing mark. 12 is the incorporated inside the receptacles, the hidden tamper-resistant shutter mechanism. You can't see it, but it's in there. 13 is the grounding connection, has a green screw head. The COALR symbol means that the device is suitable for use with copper, aluminum, or copper-clad aluminum wire. The CO in the symbol stands for copper, while ALR stands for aluminum revised. The COALR symbol replaced the earlier CUAL mark, which appeared on wiring devices that were later found to be inadequate for use with aluminum wire in the 15 amp to 20 amp range. Therefore, any receptacle or wall switch marked with CUAL configuration or anything other than COALR should be used only for copper wire. (6.2.0) Lighting controls. NEC Article 404 covers information pertaining to switches. A single pole snap switch consists of a device containing two stationary current carrying elements, a moving current carrying element, a toggle handle, a spring, and a housing. When the contacts are open, the circuit is broken and no current flows. When the moving element is closed by manually flipping the toggle handle, the contacts complete the circuit and the lamp is energized. So here's the internal workings of this switch with a contact bar and two screws. And when you turn the toggle and it closes this contact bar, the switch is closed, making the connection, allowing current to flow. Switch operation, closed contact. So here's the closed contact, now the light's lit up. The single pole quiet switch shown in figure 74 is the most common switch for use in lighting applications. Its operation is much quieter than the snap action switch. Quiet switches are common for loads from 10 amps to 20 amps that are available in single pole, three-way, and four-way configurations. I'll let you go over all these. 6.2.1 Three-way switches. Three-way switches control one or more lamps from two different locations. For example, for a basement light, you might have a switch at the top and bottom of the basement stairway. In a room that has two entrances, you might have a switch at each entrance. Figure 75 shows a typical three-way switch. So here's a typical three-way switch. It has a common screw and two travelers. The two travelers are the same color. The common screw is of a different color. So the way it works is you've got two three-way switches, and I'm not gonna say these are drawn exactly as in the real world. These are just representative. So you might have two screws on one side, one screw on the other side, and I don't know that the two travelers are on the same side of the screw. Sometimes the two travelers, the switch. Sometimes the travelers are on the top of the switch, and the common is on the bottom of the switch. But this is the way they have it drawn. So we can see that the hot comes in and goes to one of the common. You have two travelers running between the two traveler screws. And then the other common is the switch leg going to the light. So that when both of these switches are up, the circuit is made and the light is on. You can turn either one of these switches to the down position, and now there's not a continuous path for current to flow, and the light goes out. But when you turn this switch down again, now the two of them are on the bottom traveler, and there's continuity throughout the system, and the light comes on. Okay, that's how they work. In practice, to control the operation of a lamp, the exact wiring of the two three-way switches will be slightly different from the routing shown in the switch diagram. There are several ways to connect two three-way switches to control the same lamp from two locations. The method is shown in figure 77. So on this, they'll have three conductor running between the two three-way switches with the home run coming from one of the three-way switches. So you have a black coming in with a white, The white is just going to travel through the switch, not connected to the switch and going to the light. Then the black and the red conductors will be the travelers between the two three-way switches. And then this last piece is 14.2. It has a black and a white. The black is the switch leg and the white is the neutral. Again, here's the diagram of the two three-way switches. Come in with a hot, one of the common, and the other common is the switch leg going to the light. Two traveler screws just have two travelers running between the two switches. And you never put a splice in a traveler. If you have a traveler, it goes from one screw to another screw, and that's it. If you're putting a wire nut on a traveler, you're making a mistake. Don't ever put a wire nut on a traveler. Don't take the hot and go to this common and then bypass the switches and put the same hot on this other switch. If you do that, the switches are bypassed and they will not control the light. Let's see what the four-way switch is all about. Four-way switches. So you can use two three-way switches to control a load from two different locations. If you want to control that load from three or more locations, you're going to use two three-way switches and any number of four-way switches between them. When you want to be able to control lighting from three or more locations, use a four-way switch. Any number of four-way switches may be used in combination with two three-way switches, but two three-way switches are always necessary for the correct operation of one or more four-way switches. Well, here's a four-way switch. The four-way switch, the contact bars are either parallel or they're crossing each other. When they're crossing, they are not making electrical connection between them. They're separated. They're just going crisscross. So in this case, these two three-way switches are operating just like they were before. If both of these contact bars are in the up position, the current is going through the upper traveler, and then it's going through the switch leg, through the light, and the light is lit up. But now you can control the light from this three-way, you can control the light from this three-way, you can turn it on or off, and you can also turn it on or off from this four-way. If we were to switch this four-way switch, we would go from the parallel configuration to the X configuration. And this current going through this traveler would be going down to the bottom traveler, and it would dead end right here. And the light would not be on. I really shouldn't say current because when the light is off, there is no current flow. But it's the potential, it's the voltage. The voltage is on the upper traveler, and then it would go down through the crossed travelers or contact bars to the lower traveler, and it would dead end right at this traveler screw. It would not continue on. The light would be off. A hot wire is connected to the common terminal of the three-way switch on the left. Current then travels to the top traveler terminal and continues on the top traveler conductor to the four-way switch. Because the handle is up on the four-way switch, current flows through the top terminals of the switch and into the traveler conductor going to the other three-way switch. With the switch in the up position, current is carried from the top traveler terminal to the common terminal and then to the light fixture and energizes it. Now, in this scenario, they've switched to the four-way switch. The two three-way switches are still in their original position, but by crossing the contact bars in the four-way switch, you can see that the potential is going through that contact bar, ending up on the lower traveler, and it dead ends at the lower traveler. The light is not working. 6.2.3, working with photoelectric switches. The chief use of the photoelectric switch is to control outdoor lighting. You'll find them frequently in use from dusk to dawn lights in suburban areas. This switch has an endless number of possible uses and is a great tool for the electrician dealing with outdoor lighting situations. So this can turn the light on when the sun goes down and it gets dark. It'll turn the lights on and they'll stay on until dawn, till morning when the sun starts to come up. It'll sense the presence of light and it'll turn off the lights. 6.2.4, exploring relays for remote control lighting. Next to switches, relays play the most important part in controlling lights. However, the design and application of relays are beyond the scope of this module. This brief explanation or exploration of relays for remote control lighting will add to your knowledge of lighting controls. An electric relay is a device that uses an electric current to cause the opening or closing of one or more pairs of contacts. These contacts can usually control much more power than is necessary to operate the relay itself. This is one of the main advantages of relays. One popular use of the relay is to provide remote control lighting in residential systems. It's also useful for rewiring existing homes with finished walls and ceilings. So, if they're not going to explain the workings of them, I'm just going to go on. Here's a dimmer. Dimmers have evolved, so have lights. At one time we had incandescent lights and a rotary dimmer. It was a rheostat. It was a variable resistor. And that variable resistor would change the amount of voltage going to the light, to the incandescent light, and the lower the voltage, the dimmer the light. So you could control that light from full brightness to off using that dimmer. Then they came out with fluorescent, compact fluorescents, and you couldn't use a rheostat on fluorescent lighting. So they came out with a dimmer that did not dim the voltage, it dims the current. We used to have to buy a special dimming ballast for fluorescent lights, and we had to use a special fluorescent dimmer to make sure that we didn't burn up the ballast in the fluorescent light. If you dimmed the voltage to the fluorescent ballast, you would burn it up. So they would use special dimmers. Nowadays we have LED, we have compact fluorescent, we have incandescent, and they sell dimmers at Home Depot that handle all of them. It says right on it, good for incandescent, LED, CFR, they can dim anything. A dimmer is a device that you connect to a lighting fixture to use to lower the brightness of the light. Dimming a lighting system provides control of the quantity of illumination. Dimmers may be used to create certain modes or moods, or to blend the lighting from different sources for various lighting effects. Figure 81 shows some of the uses of a dimmer. Dimmers are very convenient. Some of them are just two-wire devices, and you can take a single pole switch out and put a dimmer in its place, and you can dim the lighting in a room, and it's very convenient. So the position of the dimmer slider is directly proportional to the intensity of the light. Here they have the neutral coming, and they've actually taken the neutral to this. I'm wondering if this is an electronic dimmer. If it uses a neutral, it's probably an electronic dimmer. And then the hot goes to the dimmer and feeds it. Then they have the red switch leg coming to the light. So the hot is feeding the electronic dimmer, and the neutral is allowing the dimmer to use a small portion of that electricity to power it, and then the output is on the red switch leg, and it can vary the output of that switch leg. Dimmer set to maximum brightness. Here they've moved the handle halfway down. The dimmer is set to dim illumination, and the light is a lot dimmer, and then they slid it all the way down, and look, the light has gone out. Dimmer is set to off. It's very important that dimmers be matched to the wattage and type of application. Check the manufacturer's data. 6.2.6 switch locations. Again, if you look in Article 210.70, it tells you everywhere where you have to. In fact, let's do that. Let's look at 210.70 and look at switches. Here's 210.70 lighting outlets required. Lighting outlets shall be installed where specified in 21070A, B, and C. The switch or wall-mounted control device shall not rely exclusively on a battery unless a means is provided for automatically energizing the lighting outlet upon battery failure. A. Dwelling units. In dwelling units, lighting outlets shall be installed in accordance with 21070A1 and 2. Every habitable room. Habitable rooms, kitchens, laundry areas, and bathrooms. At least one lighting outlet controlled by a listed wall-mounted control device shall be installed in every habitable room, kitchen, laundry room, and bathroom. The wall-mounted control device shall be located near the entrance of the room on a wall. And then they give you an exception. They say you can use an occupancy sensor if it's located in the same location as the switch and has a button to override it. In other than kitchens, laundry areas, and bathrooms, one or more receptacles controlled by a listed wall-mounted control device shall be permitted in lieu of lighting outlets. So that's giving the contractor permission to just half switch a receptacle and use that as the lighting outlet. It's a lot less expensive. Exception number 2, lighting outlets shall be permitted to be controlled by occupancy sensors that are 1, in addition to listed wall-mounted control devices, or 2, located at a customary wall switch location and equipped with a manual override that will allow the sensor to function as a wall switch. And then 2 additional locations, additional lighting outlets shall be installed in accordance with the following. At least one lighting outlet controlled by a listed wall-mounted control device shall be installed in hallways, stairways, attached garages, detached garages, and accessory buildings with electric power. For dwelling units, attached garages, and detached garages with electric power, at least one exterior lighting outlet controlled by a listed wall-mounted control device shall be installed to provide illumination on the exterior side of outdoor entrances or exits with grade level access. A vehicle door in a garage shall not be considered as an outdoor entrance or exit. So every exit from your house to the outdoors has to have a light on the outside of the house with a switch inside the door so you can turn it on, illuminate where you're going to be walking so you're not walking out into the darkness. Exception to number 2, for an outdoor grade level bulkhead door with stairway access to a sub-grade level basement. The required lighting outlet that provides illumination on the stairway steps shall be permitted to be located in the basement interior within 5 feet horizontally of the bottommost stair riser. This interior lighting outlet shall be permitted to be controlled by a listed wall-mounted control device or by a unit switch of the interior luminaire or interior lamp holder. And 3, where lighting outlets are installed for an interior stairway with 6 or more risers between floor levels, there shall be a listed wall-mounted control device at each floor level and at each landing level that includes a stairway entry to control the lighting outlets. So that's the 3-way switches we were just talking about. Stairways have to have 3-way and 4-way switches depending on how many landings that stairwell has. Exception to 1, 2, and 3, remote, central, or automatic control of lighting shall be permitted in hallways, stairways, and in outdoor entrances. Dimmer control of lighting outlets installed in accordance with 21070A23 shall not be permitted unless the listed control device can provide dimming control to maximum brightness at each control location for the interior stairway illumination. All right, very good. And so this says, for example, the NEC requires adequate light in areas where heating, ventilating, and air conditioning equipment is placed. Furthermore, these lights must be conveniently controlled so that the homeowner and service personnel do not have to enter a dark area where they might come in contact with dangerous equipment. So if you have an air handler in your attic, you have to have a light by the air handler in your attic controlled by a switch that's at the scuttle hole. So when you go up the stairs or a ladder into the attic and you're in the scuttle hole while you're still on the ladder, you should be able to reach up and reach the switch to turn on the lights by the equipment, illuminating the attic so that you can get up into the attic and you have illumination. Figure 82 summarizes some of the NEC requirements for light and switch placement in a home. For further details, refer to NEC Article 210. For specific locations and dwelling units, see Section 210.70A. That's what we were just reading. So here, you have HVAC equipment in the attic. You have to have a light illuminating that equipment, and the switch has to be at the scuttle hole. On stairwells or stairways, you have to have three-way switches at the top and bottom of the stairway, illuminating the lights. Any outdoor, well, this is the furnace. You have to have a switch where you have this equipment in the furnace room. You have to have that light. There's HVAC equipment in a crawl space underneath the house. If it's HVAC or if it's serviceable, you have to have a receptacle within 20 feet of it, and you have to have a light, and the light has to be controlled by a switch at the entryway to the crawl space underneath the house. 6.2.7 Low voltage electrical systems. Conventional lighting systems operate and are controlled by the same system voltage, generally 120 volts in residential lighting circuits. If you need extensive or complex lighting control, you might prefer a low voltage system. The NEC permits the use of low voltage systems to control lighting circuits. While there are several advantages to low voltage electrical systems, one distinct advantage is that you can easily control lighting from several different locations. This can be accomplished by using remote control systems. For example, outside flood lighting can be controlled from several rooms in a house. The control wiring costs less because it's rated for a lower voltage and only carries a minimum amount of current compared to a standard lighting system. When extensive or complex lighting control is required, low voltage systems are preferred. Also, because these circuits are low energy circuits, circuit protection is not required. So here's outdoor lighting, and it's low voltage. Here's a photo eye, and here is, I think, a timer. Let's see what they say here. What do they have here? One is the cost of control wiring is less due to the lower voltage and minimal current compared to standard lighting systems. 2, it's easier to control the lighting system from several different locations. So here are 2 different locations. And 3, low energy circuits do not need circuit protection installed. All right, let's see what else. .3.0 Residential swimming pools, spas, and hot tubs. The NEC recognizes the potential danger of electrical shock to persons in swimming pools, wading pools, therapeutic pools, or near decorative pools or fountains. This shock could occur from electric potential in the water itself or as a result of a person in the water or wet area touching an enclosure that is not at equal potential. NEC Article 680 provides rules for the safe installation and maintenance of electrical equipment and wiring in or adjacent to swimming pools and similar locations such as spas or hot tubs. Let's see here. So you have to have a receptacle no closer than 6 feet, and I think no further than, God, I want to say 10 feet. It might be 20 feet from the inside wall of the pool. It has to be a minimum of 5 feet away from a switch on a wall. If you have like floodlights or you have a switch on your house, your pool has to be a minimum of 5 feet away from it. Paddle fans and lights have to be a minimum of 7 foot 6 inches above the highest water level. Let's see what else does it say here. These are different sections. Receptacles is 680.43A1. Wall switches are 680.43C. Luminaires, outlets, and ceiling fans that are GFCI protected, NEC 680.43B. Maintenance disconnects, 680.13. Electrical equipment, 680.43F. Supply receptacles, 680.43A3. In addition to NEC requirements for swimming pool installations, There are other good sources of information about electrical installations in and around swimming pools, such as manufacturers of swimming pool equipment, including those who manufacture and distribute underwater luminaires. Many of these manufacturers offer pamphlets detailing the installation of their equipment with helpful illustrations, code explanations, and similar details. This literature is usually available at little or no cost to qualified personnel. Visit manufacturer websites to request information, browse available literature, or contact your local electrical supplier or contractor who specializes in installing residential swimming pools. And here they're talking about the drop to the house. This is actually probably, yeah, has to be a minimum of 10 feet above the high level water mark in the pool. And again, we have to be at least 6 feet away from the receptacle and 5 feet away from a switch on a wall on the house. The luminaire transformer. You don't have to have low voltage lighting in a swimming pool. I think it's a great idea. I would recommend it, but you can have 120 volt lighting in your swimming pool. The caveat is that you have to have an isolation transformer that is 120 to 120. It's a 1-to-1 isolation transformer, and it has to be fed off of a GFCI circuit, so that if anything ever goes wrong, it's going to trip the circuit and disconnect the power before anyone gets hurt. Okay, let's go on here. 6.0.0 section review. Says the brass screw on a receptacle connects to which wire? The correct operation of a four-way switch requires what? And the minimum distance between a receptacle and the inside wall of the hot tub is how many feet? Very good. All right. Well, this concludes Module 26.111, residential wiring. I hope you got something out of it. If you did, give me a thumbs up. Consider subscribing to my channel. As always, I'll see you on the next video. Thank you. Hey, this is Brian Young. If you liked my video, please give it a thumbs up and consider subscribing. I'll see you on the next video.